Hello, and welcome back to our People and Culture Management System series. This series is brought to you by Prairie HR Solutions. My name is Jake Finger, founder and principal consultant of Prairie HR Solutions. And in this series, we are building a people and culture management system module by module. Right now, we're currently on the total rewards module, particularly our salary analysis information or dashboard. If you've watched our previous videos, it may look a little bit different. Really, the only thing that I did differently from our previous series was took the division and job title and pulled it out of this area and broke it into sections. So we have a controls and filter. This controls our trend line for our chart here. And our filters are still the same. As you can see, we can still filter by job title as well as division. There we go. Took a little second there. I'm having a great windstorm, so the internet's going a little bit weird right now. But um, and then what I did with our analysis piece, if you remember, we found the linear regression and the R squared. I put it down here into an analytics piece because what I would like to do eventually is kind of expand this out a little bit. Um, Anytime that we have a dashboard, especially with compensation, a dashboard is going to lead to more functionality. I've always found when you have a dashboard, a dashboard can turn into a monster really. There's a lot of things that you would like to drill into or kind of see differently or even model out in the future. Like if we look at this data right here, there could be instances of us wanting to adjust a lot of individuals' pay. So we're going to need to run modeling, and that's a little bit out of scope for this PCM here currently. But if I was doing this in a different situation, I would be building out a modeling piece, and that's coming down the line. But for right now, um, that's a little bit out of our scope. But to build onto this, I took the analytics so we can build that additional functionality down here below it. And particularly maybe making this a little bit bigger, zooming functions and stuff like that. But you'll notice that there are two additional fields here. We have the salary standard deviation and the experience standard deviation. So what the standard deviation is how far the data exists out away from the mean or the average. So this R squared tells us the correlation between salary and experience. And of course, one is a perfect correlation, whether it's positive one or negative one. And right now we are sitting at a very, very, very low correlation between salary and experience. We cannot say that there is a correlation in the pay for an individual based on experience. And that's true because, I mean, if you look at this, you're seeing that there are data points all over the place. Now, a good positive correlation would be each one of these points is either right at or close to this trend line here. That would be a good correlation to say that our fictitious organization here pays based on an increase in experience or whatever the situation is. But I would like to find the salary, how far the points are away from our average, as well as the experience, how far the experience is. Because what happens is from the standard deviation, you can tell essentially if your data is lopsided or not. If you have a very greenish, if most of your data points are here in the, 0 to 5 year mark, and you can see this here But with a number, you're able to do a little bit more with it. And one of the neat things with standard deviations, it's not neat, but it's definitely something that is very valuable and almost a necessity when you're dealing with defending compensation decisions, is within certain standard deviations. And we'll get into this with a series on our compensation analysis tutorial. Within a various number of standard deviations, you can enhance your legal defensibility because there's already case laws to determine that one, statistics is valid when it comes to either disparate impact or pay disparities. And two, it creates a consistent practice. If you ensure that you're within, say, two standard deviations, which is legally defensible, then it enhances your divisibility if a employee or somebody comes up and states that is alleging that you are paying them differently based on a protected class or whatnot. So let's go ahead and find our standard deviation for our salary as well as our experience. Now, again, just like the R squared and this linear regression, this isn't going to be a math tutorial, but I will be having to obviously create a function to find this programmatically, and I'll explain high level. If you would like me to go more in depth on what a linear regression, R squared, and standard deviation is as it relates to compensation, I'll be more than happy to. Just let me know. Our email is inside the description. But for now, we're just going to create a function to find both of these and populate it in here. Now, in order to find a standard deviation, we are going to need to calculate, obviously, the mean or the average, and we've done that. We've created that helper function called calculate average. So we can just grab that and then send data to it and have it return our average. And then what we're also going to need to do is calculate the variance. And to calculate the variance, what we need to do is we need to find the sum of the squared differences from the mean and then divide that by our total number. So we can do that. And then the standard deviation is simply the square root of the variance. So let's jump here into our code and create this calculate standard deviation function. So we already have our calculate linear regression, and we have our calculate R squared. So let's come down here and right underneath this, and when we get this working, I'll take all three of these and move it over to our JS file, our JavaScript file. So let's just create this function, and we'll call it the same way we did with the others, calculate standard deviation. And what we're first going to need to do is find the mean. So create a constant, say the mean, and this mean is going to jump into our calculate average function. And if you have no idea what it is that I'm talking about, please go back and watch our previous videos, because in our previous videos, what we did was we created a function to find our average and our sum, to where all we had to do was pass an array of numbers in here. It would find it and then return the average. So that's really what we're doing now with our standard deviation. But what we need to do is we need to use this calculate average, send information over to it, and then store the results in a variable. And we will just say that this is going to take data. And what this is going to receive is data. And maybe we'll change this later on, but for right now, we'll just use that as a placeholder. So that's going to be our mean. And then we need to find the squared differences before we find the variance. So we need to find the squared differences in order to essentially divide that by that total number. So let's create this squared differences variable. And what this is going to be equal to is we're essentially going to map a value And then we're going to pass that math.pow thing, this. And what this function does is, let's delineate here. Let's explain what this math pow is, because I got an email asking me what it was from our last video. And so I'd like to explain that here. What this is this takes a value and multiplies it by a power. So the syntax for this is math.pow, and it's going to be the base value times the power multiplier. I guess I could just put, it's the word I'm thinking for, not power exponent. That's the word I'm looking for, exponent. So what we need to do right now is find the base. So when we look up here, this is the base value. This is the value that we need. So when it does this calculation, this is going to be the base, and then this is what we're going to raise it to the power of. So this is going to be just squared. So what we're going to do here is our squared differences needs to be equal to math pow, and the base is going to be essentially, no, excuse me, we got to map it first. We're taking the data and we want to map it. And for every value that we come across within this data, then we want to do our math power. I got sidetracked trying to explain what math.power is. Then for every value, we want to run a callback function, and that function is going to give us math pow. And what we need to do is we need to grab this value and we need to subtract the mean, because remember, in order to find the squared differences from the mean, we need to subtract the squared differences, which we're putting in this value. So we need to subtract the mean. And then what we're going to need to do is raise that by the power of 2, or square it. So that will give us our squared differences for every element within this array. And then it'll store it in this variable in an array. And then what we can do is take that array and find the variance. So let's create a constant, and we'll call it variance. And this variance is going to equal our squared differences. And what we're going to do is we are going to use reduce. Now remember, the reduce method takes an array and attempts to provide, well, it doesn't attempt, it gives you one number. Now we used reduce in our calculate average. So we had an accumulator, and then we had the value. So what it was essentially doing was taking that value and adding it to the accumulator for every element in that array. So that's what we're going to do here, except our array is going to be called squared differences. And instead of using that ACK val, let's just use A and B for right now. So it's going to take A and B. And then for A and B, it's going to want to run a function. And that function is going to be simply A plus B. A plus B. And then we need to give it a starting point, and that starting point is going to be 0. And then our formula says that to find the variance, we sum up all those square differences, and that's what we're doing right here. We're summing it up. And then we need to divide by the total number. So it would be the length of this data. So we can just divide data dot length. And that is going to give us our variance. So now what we can do is find the standard deviation of this by simply finding the square root of that variance. So we can do this by another math method. And this math method is going to be the square root. And the square root we're trying to find is the variance. Okay, cool. So now we have a function to calculate our standard deviation. And what we're going to need to do now is while we're here, let's go ahead and do a function to display the standard deviation while we're down here. Just like we did with our regression values. This one right here. I guess we can move it up here to where it's even. Okay, right. We'll just put it right here. And what we're going to want this standard deviation function to do is, one, we're going to need the standard deviation, of course. But then let's go ahead and pass the element ID in here as well as a separate argument. So let's pass an argument called the standard div, and then we'll just call it the element ID. And then what we can use is a constant, and we'll follow the same logic here, len reg box, except this time it'll be stand dev box. And this will be equal to document dot get element by ID. And the reason I'm doing it this way is we are going to find the standard deviation of our salary and the standard deviation of our experience. So this way we can just use this one box. So we're going to run this twice, once for our experience, once for our salary. And instead of having to pass various things through it, we'll just pass the ID of each. And then instead of having a set ID in here, we can just pass whatever. Go ahead and make this that way. There we go. We can pass whatever value that is in there. Okay, good. So we have that. And of course, we really should check. We'll do our typical debugging check here. If the standard deviation box is actually there and present, what we want to do is take that standard deviation box and set the value to standard deviation, and we're using to fix 2, so we'll keep it that way. And then let's give it an else. So else console error, and we'll just say element not found. That way we can tell if we jumped the gun and called this before that element was ready. Because remember, this is all in the head. So it's running first thing. We just got to make sure that it doesn't get ahead of this standard deviation boxes being populated. Okay, cool. So now we have our two functions. So now what we need to do is build this into our chart function. So let's go up to where we have our R squared in our chart. Okay, so here's this, and we'll just do it right below it. And what we're going to do is let's create a constant, and we will call this salary std dev. And this is going to calculate the standard deviation. And this is going to take, obviously, our salaries array. And then let's create another constant variable and call this experience std dev. And this is also going to be calculate standard deviation, except it's going to be experience. Let's make sure we got that right. And there's no, yep, okay. So now it's going to run the salary, of course, stored in this variable. Then it's going to store this in the variable. And that is after it's produced this slope, our linear regression, and our R squared. And then what we can do is display standard deviation. And what we're going to pass through this is the salary standard deviation and the string ID that it is. So let's go down here and find what we called it here. Comp salary std. So let's just grab that, copy it, and we'll come back up here and put that in there because it's going to pass this argument as a string. So it's simply just going to use this as our element ID and populate it in there. Like so. Now what we can do is take this and do the same exact thing for our experience. And it's not going to take the salary, it's going to take the experience standard deviation. And instead of this, it's going to be BXP. Let's go make sure that that's correct. EXP STD. Okay, good. So now that should do it. So let's go ahead and save it and see what we got. Let's see if it actually produces a standard deviation into something that we can use. Because then what we can do is we can then create the logic and say that, okay, this is obviously well below the threshold. We don't want an R square like that if we're saying that we pay salary based on experience. So we can make this, we can run a check and make this entire box red. We can make this linear regression red if, say, this slope is negative. That means that we're paying less by experience on average. So if it's a negative number, we can make this red. And then we can do the same thing with our salary standard deviation experience, depending on your organization, I guess. But really, we can color code this to where when you're looking at this dashboard, you can just quickly look, ooh, we have an issue here. And simply, without having to look at the number, you can see it within the color. So let's go ahead and refresh this and see what we got. Okay, charts produced, all that's produced. And okay, good. Good. So what this is meaning is that the standard deviation increments are 39,916. So 30, 30, 30, 30, 30, on and on, both ways past the average. And our experience standard deviation is 5 years plus or minus from the mean. So every 5 years is its own standard deviation, 1, 2 standard deviations, 3 standard deviations, and so on. So let's check to make sure that we can continue to change this through our filters there. Yep, filters are good. That's good. Okay. Now, the reason why this salary standard deviation is 32,000 is, remember, this is annual. So this data point is $105,000 per year. Now, this would be less, this wouldn't be such a high number if we did it by, say, monthly. But this is the standard deviation in base pay from the average. Okay, perfect. Good. So now we have a function that calculates our standard deviation. And we have one for our linear regression, our R squared, as well as both experience and salary. Good. So now what we can start doing is I'm going to focus on cleaning this up a little bit, maybe making some styling differences. And then our next video, what we'll do is we will then work on our benefits information. I know that charts was very quick. Charts are difficult, at least they were for me, to really wrap my head around in building the code to get them to display properly, particularly Google Charts. So, the upcoming series episodes, what I will do is I'll take our benefits data, and instead of using a scatter plot, we'll do a different type of chart and then build it from scratch so you can see and get reinforced what's actually occurring inside our chart data. So if you've appreciated and this is helpful, uh, please hit that subscribe button. And until next time, please take care.